Hello, everybody. I think we can start now. I am Enrique Barra. I work for Polytechnic University of Madrid, and we are here today for Module 5 of Innovative Practice for Engaging STEM Teaching. Today, Eduardo Lostal is with us. He works at BIFI, Biocomputation and Physics of Complex Systems, here in Spain, in Zaragoza. He will be showing us how is his life, how does he his work, what has he studied, everything about what do they there. For example, they do a lot of physics of complex system, biocomputation, citizen science. That it is very interesting because students can participate in science. You can make any kind of questions through the chat, and I will be the moderator, the facilitator of the session, and I will stop Eduardo and ask him the questions. So, hello, Eduardo. You can share your desktop now.
Well, good afternoon, everybody. Thank you, Enrique, for such a nice introduction, and for the organizers of this work seminar for giving the chance to us to present our work. My name is Eduardo. I'm a computer scientist in the field, and my work here within the BIFI. This is the standard for University Institution of Biocomputation and Physics of Complex Systems at the University of Zaragoza. So what we here we have 4 main areas of work. That, as you can see, I guess everything is okay. You can see my desktop properly. So here you have in this slide the 4 main areas of the institute. One is the biochemistry and the MSD. Another one is the biophysics. Other one is the physics, and finally computation. You can see here it's a multidisciplinary institute where different backgrounds are mixed. For instance, as I said, I'm a computer scientist, but me that I work in the citizen science field, as you can see on the bottom right, I have the chance to collaborate with other areas. So it's pretty interesting because here are biologists, are mathematicians, physicists, are biotechnologists. So it's pretty interesting the work here. We are really there are a lot of projects in which we mix all together. And for instance, most of the physics projects are based on computation. So we develop infrastructures to support this kind of research on the other fields. Also, a lot of biotechnology is based on computation, on calculation. So the work is really, the people here are really involved in all the projects together. So the first area is biochemistry. The main topics in which we work is protein folding and molecular design, the flow enzymes, action mechanisms, and biotechnology related to the flow enzymes, the genetic regulation and physiology of cyanobacteria, the stem cells and apoptosis, and the studies on microsystem and technology, and the drug delivery. This area is one of the most fruitful, and actually one of the, first I should have started with the index or the structure of the presentation. First, I will present briefly what is the whole institute and these areas and the infrastructure, and I quickly focus on the citizen science area. That is the one that I think, given you are teachers, might be more interesting because we engage the students on that. And it's the one that I'm working, so it's easier for me to talk deeply about it. And actually say that because the stem cells and apoptosis is one of the projects that we are running on citizen science. So we'll talk later about it. The second area is biophysics. We study the protein folding and the molecular design, the biomolecular interactions, the glycosyl transferases and hydrolases involved in human diseases, system biology, physical modeling of biomolecules, molecular dynamics and electronic structure, and flow enzymes, in which concerns on action mechanisms and biotechnology on that part. These two main parts are a bit more separated to the other ones since they are the bio part of the institute. The other part is the other two parts are physics and computation that usually work a lot together. Physics, we work with spin lattices, the physical modeling of biomolecules, complex systems and networks, molecular dynamics and electronic structure, and econophysics, nonlinear models, and complexity. In the physics area, one of the most important are the complex systems area that study the complexity of huge networks. That's the way. For instance, now we are about to start a new project in which we study some correlations among the several layers that social networks might have. For instance, how is the interactions among the people in different social networks that might be linked, like Facebook and Flickr, for instance, or Instagram. So it's a pretty interesting area, and it's in most of it. It's the basics. The basis of these studies are centered also on the computation. For instance, spin lattices needs a lot of simulations that have to be done through high technology computers. Actually, the spin lattice, we have a dedicated resources computer that it's structured at this time only to work in this kind of project. So it's optimized to their operations are optimized to carry out these calculations. The last part it's computation, in which we also can find several topics from high-performance computing, grid and cloud computing, citizen science, and special purpose computers. The later, it's what I just said for the computers that we built for spin lattice. What we develop are computers whose purpose is focused on an area. So we optimize the construction of these computers in order to optimize their operations for a small set of operations to carry out quickly the calculations that we need in a specific problem. The high-performance computing it's also focused on not only high-performance computing, but mainly, and also grid and cloud computing, are focused on give support to the other areas of the institute, or even out of the institute to other researchers who need who may need some computers to carry out algorithms. I mean, what we do is to give support to researchers to use our resources to carry out the research project. So the research is focused in how to improve these machines, the hardware, to produce a better computer to carry out this research. In such a way, here within the institute, we have a cluster that contains a lot of computers dedicated to several projects, and we'll see it later. Assistant science is the other area that I will talk later deeply. As you can see, given this multidisciplinary approach of the institute, we have a lot of different machines that work accordingly what the researchers need. For instance, in the bottom on the left, this microscopy it's used mainly in the stem and stem cells and apoptosis research, and it's one of the most expensive infrastructures that we count here in the institute. In what concerns to computation infrastructures, These are, well, as you can see, the image on the top right is the cluster that we have here in BIFI. Actually, what we can do is take a look here. Sorry. Here, this is a webcam that from which we can see the cluster directly online, and we can take a look. So these are some of the machines that we have here.
What is the temperature in this room? Do you have it controlled?
Yes, we do, but I'm sorry, I'm afraid I don't know it.
But it should be cold, right?
Yeah, of course. We have several systems to keep the temperature, and actually, this plastic thing that you can see as a curtain is used to keep all the air within the cluster. I mean, because the main heat is going in the back part of the computers. So the main heat is mainly focused, or not focused. Sorry, it's the main heat is just in the middle of the room. That's why the cooling system is centered on provide the cool to that part. And that's why we, in this year, we did an investment, not only the plastic things, but we did a huge investment to improve the energy consumption of the room. And one of the things is that plastic things that keep the cool that is coming to that part of the computers there, and so we avoid the leakage of the cooling system out of the room. That is what one of the huge energy consumptions that had. So actually, I don't know the exact temperature, but must be low. Otherwise, because the computers have a lot of consumption, and the heat is huge. Mainly now in this time of the year. So what I wanted to show you, that's a special computer that I told you before. Is this one? I'm sorry, the door is open, so we cannot see it properly. But here is the computer that we built with the special purpose on working on spin glasses. This all on the left are from old projects that are not old projects, that was called Video Grid, whose goal was to join the initiative of research in the South France and the north of Spain. Aquitaine, Aragon, and all these regions were linked together, and among other resources that we built in a distributed system were provided to the researchers on those regions to work on this project. So now they are still there in order to support what the other researchers may need.
So when you finish one project, you still can use your machines, right, for other projects?
Yes, and indeed, the point of this project, Video Grid, it was to build such infrastructure. I mean, what we got from that project was money to create some part of the cluster. So in that moment, we could serve to other projects as a resource. But the main goal was to build that infrastructure in order to, in the future, we can it might be used to other researchers that can need it. So yeah. Okay. Sorry. And now I think those on the right are one of the most recent acquisitions from the institute, and it's the more powerful machine that we have now. But I think that we can quit. Sorry. This is what we have here. So These are the computers that we just saw in the webcam. Janus, this one with that is built up to 256 FPGAs. Is a special purpose computer that used for the spin classes. The one on the right that I told you that were the newest acquisitions are the ones used for cloud computing. Is controlled by the OpenStack framework, and it has up to 8 years of storage and more than 250 cores working at the same time. PeerGrid, you can see in the left. It was the machine that we had at the moment, but after the project, some of the machines were integrated to build the cloud ones. So the powerful now is not up to 9 terabytes, but the cloud actually is a bit greater than the 8 terabytes that I told you. The Menta is another machine that we have here, one of the most powerful also. And Ibercivis is the voluntary computing machine that we have here. It controls all the volunteer computing infrastructure that I will tell you about before. Also, what concerns to computation infrastructure, they have a 3D room that you can see in the image of the bottom right, that contains a passive and active storage infrastructure and immersion system. We develop some projects based on 3D, like a solar system kind of game, in which through the users of the movements of the user, they can control the movement around the solar system. So it was initially deployed for a school here in Zaragoza, and it's a really interesting system. So it's almost a game in which the students on primary school work for astronomy. I mean, they study astronomy through the use of this system in which they can move through the whole solar system. So this that are another kind of projects that we work in the computation section. Another interesting part also for the teachers is the augmented reality part. We develop some projects like the one on the left and the bottom that simulate some physics problems. For instance, this is the typical one of the, I don't know how is the name in English, sorry, to the movement of, sorry, maybe Enrique, you can help me on that part. You know, this kind of movement, and with the acceleration counts. So we start through a computer, we can control the red thing, the red thing that.
It is a pendulum, right?
Yeah, exactly. Sorry, I didn't remember the name in English. So in such a way, we can the student can estimate the coordinates in which they should drop the red thing in order to calculate the pendulum move that it does. So it's applied for physics, and we also are doing some kind of this works. Well. I'm going to go deeply in the citizen science section. We and the Ibercivis Foundation, that is a kind of startup from exactly a spin-off from the institute, are working on citizen science. Citizen science, as the definition says, is a research conducted by members of the general public, not necessarily scientists who work with the data to carry out a science project. That is, what we do is trying to engage people, normal people, to carry out scientific projects. they do the same task that the researchers do. So what we are trying to do is to create a new open science paradigm where everybody can participate under the guidance of a researcher to create science. So, I mean, a lot of people can help with even with only the resources or also their mind. They can do a lot of things, and this leads us to what it's collective intelligence. That is the main topic in which citizen science is to what citizen science belongs. And well, the goal is increase interest in science and make public participants of it. That acts as a way to democratize what is science nowadays, because a user, a volunteer who has participated in science and know how science works can take a more critical decision in what science concerns. For instance, they can participate in the government decision about the investment in science, because if they have work on it, they better know how it works, what it means to do real science. Citizen science is based on scientific activities in which citizens participate in data collection, analysis, and dissemination. It must be voluntary, conscious, and informed. So they have to know what they are doing, but it's not necessary any training to do it, or better said, it's not necessary any advanced training. There are two ways of doing it. It might be active, in which the citizens particularly using their intellectual skills, resources, and time, or passive, where they only provide what are their technological resources to help processing some kind of data, to run some algorithms or some calculations. So we can define scientists.
Just for the audience to understand this, this is a very easy way for students to participate, right, in science with real science.
Thank you, Enrique. Yeah, I will go deeply on that later.
Okay.
Yeah, so citizen scientists are those who they get their intellectual skills or resources to find results, always with social utility. Which are the advantages for the citizen scientists? Well, they got new skills and knowledge on science and the technology field, develop critical thinking. It's what I tried to explain before about democratization of science. They participate in real research projects, and they participate directly. I mean, they do the work. It means also the acquisition of a real and accurate perception of science and its practice. And it means a significant contribution for the advance of science and technology. So what we like to say is that those guys are the link between science and society. On the other hand, for the researcher, the advantage is obvious. So they have a team of volunteers that can help them to generate a useful data that will be much more costly and time-consuming to obtain if without the help of a large number of people involved. Actually, in most of the cases, it would be almost impossible without the citizen collaboration. Well, this is a nice image that we like to use because somehow it makes all what means citizen science for us. From one part, science, the mix, and science and society. What we create is the democracy for all the people that can get involved. It means global challenges because it's what researchers research do. It means an enhancement of research of the people. It means openness since we open all the science to all the people. It means innovation because it's a new way to do that kind of science. Co-creation. It's mean learning because all the people involved at the end get knowledge on the field that they are working on. To do that, infrastructures and maybe namely ICT are needed most of the cases. It means a paradigm shift in which not only the researcher are the ones that do the work, but everyone can work on it, and means an empowerment of the people. As I said before, there is two kinds of participation. One more active, in which the people really work on it, and I have here some examples. Folded, first one is a puzzle game developed in the USA, where the people what they see is just a game where they have to unfold some proteins. So it's just a game in which they with the mouse they drag some parts of the protein and unfold it. But actually, they discover a new protein that is a synthetic protein that is pretty used, and it's in through the gamification they have got really important, significant research results. Out upon is a society of bird counting in USA that it's like 100 years ago. They started to count the birds so they can control the migration. And at the beginning, 100 years ago, it was done by letters. So they can control somehow how the migration and how are the population of the birds all around USA. Sorry. RipaNet.
They were asking in the chat about if pupils could participate, but we also told that yes, they can participate in any of these experiments or applications and games, right?
Sure. Actually, not only students, everyone can participate, and Fold is really nice because it's just a game, but it's really interesting what they can get only from the spare time of the people. And of course, the students can participate, and actually that's the goal of the citizen science. Without the volunteers and of students, for instance, working on it, citizen science doesn't have any sense because it's based on the people participation.
Okay, thank you.
Okay. Well, RipaNet, it's a part of InfluenzaNet. It's a European project trying to control the influenza epidemiology. Sorry. So it's just information gathering web. So people just enter if they have symptoms of the flu. In such a way, they can create through a complex network how the influenza is going through the whole Europe. Another examples are WebFM, that actually is a part of Galaxy Zoo. Galaxy Zoo is a big portal that hosts a lot of citizen science projects, and maybe actually is the most well-known project because they started with the analysis of galaxy images, and it was very widespread so quick because the astronomy people are really motivated to collaborate, and I think in the first year they almost analyzed like 1 million images. And the idea is at the beginning they started as a zoo universe. No, sorry, they started as a Galaxy Zoo where the people analyzed those galaxy images, but afterwards they created the whole portal Zoo Universe, where there are it's plenty of projects where you can collaborate directly, either analyzing the sounds of the whale, either analyzing the galaxies, or a lot of different projects, and really interesting. So I strongly recommend you to take a look at this webpage. This is what concerns to active participation, but also you can participate just donating your resources, and that is what is SETI at Home. SETI at Home started a lot of years ago as a program that it installed in your computer, and in the spare time, it runs some calculations. And the idea is to analyze the input to find extraterrestrial life out of the Earth, obviously. And it got a lot of people involved. And actually, you don't have to do nothing. You just set up the program, and whenever you don't use the computer, you can set the features of how you want the program to use your resources. So in your spare time, it will run some algorithms and get back the information to the researcher. And so Ibertibis is a foundation it's the foundation in which we work, but it started as a volunteer computing project in which a lot of projects were set. So when we prepare a program, a software that could be installed in the computers at home, so you can choose the project in which you can spend some resources and computational resources, and on the free time, it starts to run an algorithm. And so it was set at home. Actually, all of them, most of them, are based on BOINC software computing. That is a framework developed in USA for this kind of project. So in the meanwhile that I present I gave you some examples, I introduced this. These are the main four groups of experiments or work that can be doing in citizen science. On one way, we have the volunteer computing, in which the user donates the resources. We have also voluntary experiments, in which through games or similar, the volunteer collaborates without knowing exactly what they are doing. They are just playing, to say somehow. In other kind of experiments, we have the volunteer sensing, in which the user is responsible to gather some data, either with just providing some information like the flu one about your symptoms, or taking pictures or videos of something, or reporting some problems from some information from the city. So it's just a data gathering in which those data are provided to the researcher by the volunteer. Finally, the volunteer thinking, in which the user actually do the work and do the analysis or do whatever is needed. Besides this, also from BIFI, we write and we do all these kind of experiments this type of experiments focus on several projects, and also we develop, we carry out other activities, participatory activities, in which we engage people to work on it. For instance, we organize hackathons in which we part from some projects, some ideas that has to be developed. So we put together different people with different backgrounds to work on it and to create something together. What we can say as crowdsourcing, that for instance it's like a lot of open software is created, or it can be seen as a kind of crowd thinking, in which the crowd get together to work and to build something among all the members. So volunteer computing, as I said before, BOINC is the most well-known software to do it. And as you can see, this image is, I think it's from January. But as you can see, in the whole BOINC software, it has more than 2 million people, almost 3 million people working on it. You can imagine what it's 3 million computers working together. It's a huge cluster with a really the computation power. It's huge. So in this example, just looking at the numbers, you can imagine how big is what we can get if we work all together. And in this case, it's just donating the resources that you don't have to do almost nothing. So it's a really interesting and promising approach. This one is folded, the game I told you before. So as you can see, you have the proteins there, and the game consists in unfold all the proteins to find a final solution. It's really hard to do in a computational way, or it's not hard, but it's really time consuming. So the algorithm to try every solution, to try every movement that can be done without following any strategy, or not all of them, are really time consuming. I mean, it will be doing the simulation for years. But the human brain is really well prepared to see the protein and to find more quickly which are the ways to unfold it. So it's in one way in which the brain can work better of a computer and can help directly to the science. Another example of volunteer sensing is this is GripNet, as I told you before, the flu one. So you have just to fill in a questionnaire about your symptoms, and you are providing the data, so the researchers can build the network and see how the epidemic, how the flu is advancing in every region, so they can prevent a new infection, a new growing up. I mean, an increase of the disease in new ways. I mean, sorry, it was a bit confusing. So the data that the citizens are providing, they can prevent, they can know in advance how the disease, the epidemic is going to go further. So they can advise the hospitals or the people that the next week, for instance, the disease will be higher in that region. So it's helping the people to get better. So they are helping the people to be careful with some kind of disease, and it can be extrapolated to a lot of similar diseases or approach for improvement of the people's life. In the right, Epicollect, it's a framework to create your own project. It's really easy. You just have to create the questionnaire, and even online or in a app in an application, mobile application, everyone can. I mean, it's really easy. It's just creating that questionnaire. Give the chance to the creator to develop a web page and a mobile application almost out of the box. So if it spreads that application or the web application, people can collaborate and he can gather all the data for itself. So it might be useful not only for scientific projects or not for high-level projects. Also, everyone can create to their own problems. For instance, just think about traffic. If the road is not in a good state, the probability of accidents are bigger. So someone that are worried about his city can create that application and move around with their colleagues and with the people in the city, and can report through the mobile application, can report problems on the road. So the government, the local government, can work on it. So it's in such a way, this is the way in which I referred before, that it's a way of open science, because everyone can work, everyone can create the project, and through the collaboration of all the people can improve the lives of the others, and most of the projects are based on social utility. Sorry. The last set of projects, the last type of project, are the ones involved in voluntary thinking. In the left, you can see the Galaxy Zoo application about the galaxies. So, as you can see, if you take a look at the questions are anyone has to study for years astronomy to say if the galaxy is rounded or not, for instance, or the shape of the disk of the galaxy. So it's a way in which every citizen can get involved in science, can help researchers to do their work, but just giving, they are participating with their intellectual skills, but they can not do it. In the researchers couldn't do it in another way. In the right, this cloud crafting. Cloud crafting is another platform to develop science projects. And as you can see here, they are studying the size of the lichens. So that's why they are comparing the lichen size with a euro coin. And with the size of the lichens, they can somehow model how is the impact of the pollution on some region of a city. For instance, exactly these images are taken from a park, and through the crowdsourcing of the people that are taking those pictures and analyzing how big is the lichen, they can induce how the pollution are affecting at that park. Okay. Again, it's what I meant about social utility. At the same time that the researcher has the data, or a valuable data, to see how something is affecting another aspect of what they are studying. Yeah, well, this what I say about participatory activities. This one on the top. It's an image from a hackathon that we organized in Madrid, in Spain, where a lot of people was working together. As you can see, from really different ages. From the backgrounds were completely different, from physicists, from philologists. So it's really interesting. Here, I'm going to focus now on which are in the projects that we are doing here. So until now, I present on citizen science. I present what is citizen science and what are the possibilities. And I present now this project. It's called Untitled. It's a project in which BIFI, the people of BIFI, are coordinating the European project. And well, it's funded by the European Commission. The goal is twofold. On one side, the idea is to develop some science projects in order to get good and bad practices. The most important goal of the project is to write the white paper on citizen science in Europe. That it intends to provide some policy recommendations to the European Commission on how to invest in this kind of science for the future, and also provide through the experience got from the developing of such citizen science project, provide that good practices in order to help the researchers to get involved in citizen science and use it for their own project, knowing how they can do it. Okay. What? That's more or less what I say now. And yeah, the white paper or white book on citizen science, that by the way will be presented next week in Brussels. So if some of you are from there and have the chance to attend the meeting, the event, it will be carried out on next Monday in the Saclement building, and we'll present the results of the project, and a lot of people, a lot of speakers from citizen science will come to talk about, and actually people from European SchoolNet also will present some of the work done in citizen science, and actually some part of the conference will have to do also with how it involves the education, how education involves on that process. So, well, the partners, this is the website. You can take a look if you want, scientist.eu. From there, you can access the experiments. You can see it's on the top of the webpage, and yeah, that's the ones that your students can use it. These are the 6 experiments that we have developed within the project. I'm gonna go through all of them now. First one, mean path. It's a project leaded by the complex systems section here in BIFI. It's about linguistics. It tries to, the final goal is to improve the semantic analysis. So they try to understand heuristics that we try to manage the structure of concepts. To do that, what we create an application that try to define the distance between the words. So we have a semantic map of nodes of words, and through a video game, volunteers have to read a word after a given word. So we have a source word, a target word, and we have to go through the network to reach the target. In such a way, the results are important for web semantics and so on. So I can no, sorry, here. As you can see, we have the source word, that is water, and the target one, that is party. So we have the neighbors of water, and we have to try to reach party through the neighbors of water. So for instance, let's say drink, and from drink, we can, with the source word change. So we are advancing through the network to reach party, and that's the way to do it. So this is a game actually, and it's just a game, but researchers can get a lot of results from here because they can study how people move around that network. Okay, and well, what concerns your students, I don't know if it's the better one to use it, since it's just a game. And well, for instance, it's for the non-English speakers, it's useful to learn some vocabulary, but I don't know if for the rest of the students are so useful. Okay. Second one is Time for All. This is a project that was developed initially in Coimbra, in the Astronomical Observatory. They had like 15,000 images of the sun from observations that started in 1926. And the goal is to study the phenomena occurring on the surface of the sun to understand the solar activity and the solar cycle. What volunteers have to do is just to count sunspots and the sunspot groups using the application. To study of that sunspot, besides being interesting tests, present an important tool to understand much of what happens on the Earth climate. So that's the main objective of the application. And as I can show you here. So these are the images that are shown. So we can zoom on it, and we see some group of sunspots. So we can just mark it. So it's pretty useful, and it's pretty useful for the researcher that can make their work done pretty fast. Much more, instead of just having a guy doing this every time. So the crowdsourcing, they can get better results. Okay, these are the other experiments that are not still deployed. Antimatter, it's an application that we have built with the support of CERN. Actually, it's a research from the CERN in Switzerland. It's an application that tries to study the antimatter. So the user has to analyze some images that are provided from CERN directly. BIFI, it's a really interesting project. It's carried out through a consortium of people from Toulouse, France, Toulouse in France, Barcelona in Spain, and Helsinki in Finland. These are the basis of the human life. So they try to study how the bees are affected within the human environment, because that gives a clue of what is happening in the global warming change. I mean, the status of the health of the bees can give a clue of how people is affecting on the world, and how the pollution and all human life is affecting to the world, how we know it by now. And the idea is to through that consortium of people is trying to engage more people, build some intelligent beehives that can count and analyze the size and some features of the bees, so they can gather a lot of data through that beehives that have been built and placed in some strategic points around the cities. The latest, it's called 7 Ideas Home. It's a project that tries to provide some energetic advices. It tries to get information about how people work on their energy consumption at home, how are the habits, and also the data from the data from the temperature and how much energy are spending in order to get some comfort temperatures. I mean, the idea of the project is on one hand to provide advices of how to improve the energy consumption, and on the other hand, to know what are the habits and how people work on the energy consumption to improve their models on how the energy can be produced and can be saved. And well, this is the last one, not only the last, I talk about another one later, but I left this one for the last, because I think it's the one that is more interesting concerning to education, and it's for me the best example of what citizen science is. And well, this project is called Telespotting. Jose Villar is the head researcher behind the project. It studies the cell death, a kind of cell death known as apoptosis. He tries to find chemical compounds that can induce this kind of cell death, apoptosis, in tumoral cells. Obviously, this has a huge impact in treatment for diseases like cancer. So if we can produce a kind of compound that, by the way, sorry, apoptosis is a kind of death, or cell death program that only kill the cells that has to be killed, but not damaging the surrounding tissue. So for diseases like cancer, for instance, if we can just attack the correct cells, the treatment is much more, it's way better for the patient, and the treatment is really I mean, will be really good. To do that, what we do is we have I mean we have he has a microscope, actually the one that I told you before that was really expensive, and he has within the BIFI facilities that microscope that can get, I think it was like 16,000 images per day, that he has to analyze for himself, because the computer algorithms are not enough powerful to do the analysis with accuracy greater than 80%. But that 20% of difference it means a lot concerning on things like healthcare. So what we do was build an application that is online. So we upload those images that he is getting, and are available to be analyzed for everyone around the world. So the analysis that has to be done, it's actually pretty easy. It's just to say there are 4 steps. The first one is just to say if the cells are alive or dead. The second one is to mark the cells that have released some content. The third ones are concerned to the mitochondrial distribution, and the last one is to provide some remarks of some unexpected things that the volunteer has observed in the images, or another weird thing. So let me see. As you can see here, we have the image on the center, and on the right we have some samples, so we can see which are the. I mean, all that we need to do the analysis is here in every step. On the right, we have the samples, so we can compare and to analyze the image and mark the cells. Just taking a look at the samples. For instance, as you can see, we can see that this one is dead, and it's just comparing with the samples. And here we have a lot of information about every step. So students, it's not only, I mean, it can be really good for students, since a huge spectrum of students can use it from elementary school to high school, because it depends on the level of the student, can learn more or less, because they can just see the cells and save and find the nucleus, the mitochondria. Actually, we have several channels, so we can see in the blue channel we can see only the nucleus, the nuclei. In the green channel we can see only the mitochondria. So that helps the students to distinguish every part of the cell. But also, going to higher education level, we can provide them with more information, like when are alive, when are dead, but when are dead, why and how. What that means that that kind of cells have been dragged, or that what means that the cell content has been released, because these are the kind of death by apoptosis, or or which one has been done by necrosis. So it's a lot of biotechnology knowledge that can be learned just by using the application and all the information and tutorial that are available. Okay, and actually, okay, so yeah, of course, in this year and a half, we completed almost 60,000 tasks. And well, for the students, we prepare three things. One is the didactic unit that is translated to 4 languages: Portuguese, Spanish, English, and German. So teachers and so the students can use it to learn more about what concerns to the application and the biotechnology research. Also, we prepare a tutorial that is shown at the beginning, and also in every step can be accessed through the button on the application. And also a video. It was prepared to tell more about the background, about the background of the project. I mean, it's not at all about sorry. Yeah. It's not at all about the cells.
All living beings are made out of cells.
But,
plants and animals could.
Maybe that's annoying. So the idea in the video is to show what is the background that brings to work on this kind of research. What can be done through the biotechnology. We can see the microscope and what means actually the kind of depth, how the cells work and so on. So in what concerns to education, what we think or idea or lemma is this: what you hear, you forget; what you see, you remember; what you do, you understand. So what we observe is that there is a lack of motivation in the students, most of them, that we can take advantage of the new technologies to fight this lack of motivation, and that a lot of knowledge can be developed through practical experiences. That's why we created, not only from the research part and on citizen science, that is what we believe and we work on, but also from the point of view of education, can be a really interesting paradigm to be studied and to be worked on. So, what means for the students to be involved in citizen science is to actually get involved directly in what a research project is. They carry out a specific task, as we see. The task of analyzing the image cells has to be done directly through the researcher. So what they are doing are the same task that the researcher is doing. So what they develop is a feeling of playing a key role on the project. Hence, of course, they develop knowledge on the specific topic. They improve the background. After we can see through the didactic unit, it's not just analyzing the image. They can learn a lot from it, and they see how a real cell looks like out of the book. For all of this, they can start to create a scientific CV. And of course, thanks to this kind of things, they have access to first-level facilities. Imagine a school in the countryside that cannot come to our institute to see the institute and see the things and use top-level facilities. From this, they can access to do it. So we see that the greater benefits are in personal growing. They develop social and informal learning, and through citizen science projects, the citizen science project encourages them to develop self-confidence, the community feeling, and a creative work. To see how it works, we create a couple of evaluation questionnaires, one for teachers and one for the students, so we can get their opinions, and we are still processing all the ones that we got. And well, more or less, this is all that I wanted to tell you about BIFI, about our work on citizen science, and I would like to thank again to organizers to give me the chance to present, to Enrique for the moderation, and to you for listening, And I mean, if you have any question, I'll be really glad to try to answer you.
Yes, thank you to you, Eduardo. It was very interesting. For me, in my opinion, especially the cell spotting is really, really interesting. And there is one question in the chat. Let me lower my mic. They're asking if the webcam view of your computing infrastructure is available for pupils or just for you? It's just for managing.
Which one?
The webcam that you show us.
The one from the cluster.
Yeah.
I could provide the link to see. I mean, the one that I have now is for me. It's only available for me. But I can. I mean, what usually we do is to have some master user, like the one that I can move it. And what usually do is to provide another link so they can see what we are moving. So yes, the answer actually is yes. We can provide a link to see the cluster, but it should be one of us who moves the camera to provide all the views.
Do you do this kind of sessions, virtual sessions with other schools, or do you usually do this kind of sessions?
You mean to present the?
Just to virtually visit your facilities and to tell
sure.
And how they can involve students.
Sure. We do. So it's just if someone wants to do it, just get in contact with us, and we try to fix some moment. Right now we are a bit busy with the end of the project, but sure, I mean we can find a time gap, and we can do it for sure.
Okay, thank you. Because I know from me, other colleague of you, that you also have a lot of schools visiting you in person, not just virtually.
Yeah.
So you are quite open to the education community, right?
Mm-hmm. Yeah. Actually, I didn't put the link because I don't know if it's working now. But in the microscope there is another webcam to see how it works and how see how is the infrastructure ready for the operation of the microscope. But if no one is there, it's a bit boring. And actually, I don't know if I'm not sure if now it's working, but usually it is. So we can also provide some more link.
Okay, they are asking in the side if you can show again the slide with your contact, just in case they want to contact you.
The slide with the contact, sure. Wait. Yeah, actually.
They can contact you directly, or they can contact BIFI.
Okay, sorry. Yeah, I realized that it's from Session-Dice, the last slide, and not. I can give you my contact, of course, and you can contact me directly or the administrative. So may I write in the chat or something?
Okay. Also, do you have remote laboratories, right? Like the pendulum you told us.
Yes, we do, but I'm not sure. I mean, I think it cannot be accessed remotely because the idea of this experiment is to be set directly in the class or in a laboratory within the school that is deploying it. So we provide the software and we provide a replica of this thing. Because otherwise it's a bit I'm not sure. I mean, I'm not in charge of that project, and actually it's from 1 year ago, and I don't know how it's been working of that. But I mean, if we have a lot of people accessing to it, it could be a bit chaotic. So I'm not sure how it works, but I think it's I can ask, but I think.
You're working more in the area of collaborative science and citizen science.
Yeah.
In remote laboratories.
Yeah. And by the way, I forgot to mention another project, a really nice one. I mean, I don't know if we have time now or.
Yeah, just a couple of.
Yeah, I forgot to show. Let's. It's a new project on. I think I type it. Okay, keep. It's but sorry, it's not available now. I mean, I have to register and log in and so on. Well, the idea of this project, it's a collective intelligence project, and we are developing some platforms to carry out several kinds of collective intelligence experiments. That are projects in which all the people work together to find the optimal solution. So, for instance, we are now in October, I think at the end, late October, we have an experiment with 600 students that they have to solve an exam all together. I mean, they enter in the software that we have prepared, and they see the solutions that their neighbors on the network are writing. So they can bring the solutions to, I mean, they can copy actually their solutions. And the idea is that in that kind of networks, what we are researching is if in those kind of networks, the optimal solution of the crowdsourcing of the people is better than the solution of one people. So we're trying to demonstrate that the collective works better than the individual. So we have developed some platform that can be applied for several kinds of projects, in which the people can work on the solution, see the solution of the others in the network, and improve their solutions through the solution of the others. So a kind of copy and paste of the things that they like. So they can, in such a way, if everybody collaborates in that way, they can mix the solution and get the optimal solution. So
exclusively for music students?
No, not at all. And actually, we choose to start with music because it's pretty nice. I mean, because it's funny. So people are have to read the people in the way that they used to interact with the thing. So trying to start with a topic like music that everybody likes, it's a way to engage people quicker. So sorry that I'm talking too much. So the idea of the project is we have created a sequencer, and we have several tracks, and they create in every track they can put an instrument and say in which beat the instrument sounds. So that is like a sequencer works. So they have like five layers. So they can build a song of I think it's like 20 seconds, but they beat the song, and the other people can see the songs of the others, so they can like improve the songs of the other, add more instruments, they mix. So the idea is to create the final solution, the best song ever. So, and this was a project that in Sonar Festival in Barcelona, they choose us for some part of the research, because I didn't know Sonar Festival has a research part, and it was deployed there, and the samples were done by R. Rumba, that is a pretty famous DJ, hip hop DJ here in Spain, and another drummer from another another band. And it's really funny. You create your song and you can improve it from the songs of the others. And that's the kind of collective intelligence project that we are working on now, and that gives us the chance to study how the interaction. I mean, we create a network of the interaction of the people and how can they look for something together.
Okay, there is a couple of more questions. What are the 3 steps for creating a project in Epicollect? Just can you repeat them, because there is one person that arrived late. So.
Okay. Let me put the. Let me find the slide. Well, I don't remember exactly, but you can just go to Epicollect. Actually, the image in the slide is just a copy and paste from the web page. So here, oh, don't go. So you have to go to Epicollect. I think you must register. You must log in on Epicollect, and first you have to create a questionnaire. It's just to say which questions you want to be answered, and with that question you compile them, and the project is automatically created online and on the web. And actually, it also creates the Epicollect has their own mobile app, mobile application. So with that application in the mobile, you can search for the project that you have previously created online. So basically, you create a form, a questionnaire online, and you mark if you want the people to also be able to send video, images, or whatever they want. And the people can just access to the mobile application of Epicollect, search for your project, and provide your data. Just when you do that, in the mobile appears your questionnaire, and they have the chance, if you wish to, they have the chance to take pictures and send it to you. And later, it's released just online as an Excel, as a spreadsheet. You can take a look of what people have sent it to you. It's really straightforward.
Okay, thank you. There is another question. Are these projects for free, or schools have to pay a quota?
What do you mean? Which stuff? Well,
these initiatives, these projects, these games, applications, everything that you have told, it is for free for schools, for students, or do schools have to pay a quota?
No, it's everything free. Absolutely free. Actually, what we need is people to get involved and to collaborate and to work with us. So it's everything is free for sure. I mean, of course, what we want is people to participate.
Okay, thank you.
Yeah, actually participate. We're waiting for you.
Okay, thank you. So there is no more questions in the chat. We have been recording the whole session. Thank you very much, Eduardo, and thank you everybody in the chat. So
yeah, it's
now through the forums in the STEM MOOC. So now.
Yeah, sorry. Sorry. I wrote my address there. So if you want to just send a mail, or if you contact us. Yeah, thank you.
Because you wrote it to me privately.
Sorry. Well, yeah, you have there my address. So just if you need anything you need, just don't hesitate to contact me. I will be glad.
Okay. They are asking if your presentation will be available. If you can share it maybe in the forum, or to Gabriela, and she can share it.
Yeah, I will take a look, because I think I have to change some things, but yes, it will be.
Okay, perfect. Thank you very much, and thank you everybody again. Bye, Eduardo. Thank you very much.
Bye. Thanks a lot.
Bye, everybody.